Have you ever, looked around at our modern world and just wondered? I don't mean about the big headlines, but about the how. How? How is it that we can feed billions of people? And how can a tiny chip right here in your phone hold more power than, what was it, the computers that sent us to the moon? It's wild. So, today on Flick Frenzy Fest, we're going to unleash some curiosity on the secret engines of our world. We're talking about these mind-blowing industrial processes, these sort of hidden factory formulas. And they're so fundamental that, honestly, modern life would just be impossible without them. Yeah, so let's start with the food on your plate. Think about this. The nitrogen atoms, the ones that make up the proteins and DNA in your body, where do they even come from? Well, for nearly half the people on Earth, the answer is, get this, thin air. Just wow. And it's all thanks to this one discovery from, just over a century ago? It's called the Haber-Bosch process. See, before this, humanity's ability to grow food was totally chained to the amount of, natural fertilizer we could find. But then, these two brilliant minds, Fritz Haber and Carl Bosch, they devised this kind of, industrial magic, really. They figured out how to take ordinary nitrogen, just from the air we breathe, and then put it under this immense pressure. We're talking 200 times normal air pressure. Heat it up to scorching temperatures, and then, boom, force it to combine with hydrogen. And the result? Ammonia. Simple as that. And that ammonia? Well, that's the building block for synthetic fertilizer. It's basically a recipe that literally pulls food from the sky. It's incredible. This one process, it just shattered our natural limits. It allowed the global population to explode. And it's really not an exaggeration to say the Haber-Bosch process is the formula that, feeds the world. Okay, now let's shrink down. I mean way, way down. Intimate. I want you to just look at the device you're listening to this on, right? Inside, there's a microprocessor. It's like a tiny city of billions of microscopic switches. So how on earth do you build something that complex? You use this secret art, I guess you could call it, called photolithography. Okay, imagine you're trying to screen print a really, really detailed design on a t-shirt, right? Photolithography is, it's kind of like that. But instead of a t-shirt, it's a disc of pure silicon. And instead of ink, you're using a beam of deep ultraviolet light. So what they do is scientists coat the silicon wafer with this light-sensitive chemical. It's almost like old-school photographic film. Then they shine light through a mask, and that mask holds the blueprint for all the circuits. So where the light hits, a chemical reaction happens, and then the parts that weren't hit, they just get washed away. And what's left is this perfect, unbelievably tiny stencil of a circuit. Wow. And they just repeat this process over and over, adding layer upon layer, maybe 100 times or even more, building up this three-dimensional metropolis of electronics. So every single tap, every swipe, every click you make, that's a signal just racing through a city you can't even see. A whole city printed with light. Okay, so for our final discovery, I just want you to look out a window. Seriously. See how the glass is just perfectly flat? How you can see right through it, no wobbles, no distortions. Yeah, that's a modern miracle we completely take for granted. And it's all thanks to a process that is, both brutal and beautiful. It's called the float glass process. For centuries, making large, clear panes of glass was just incredibly difficult. But then, back in the 1950s, this man, Alastair Pilkington, he had this total stroke of genius. The process itself it's mesmerizing. You have this continuous glowing river of molten glass. It's over 1,000 degrees Celsius, and it's poured directly onto a perfectly smooth bed of molten tin. And because the glass is lighter, it just floats right on top. Yeah, just like oil on water. And here's the magic part. Ready? Gravity pulls the glass down, which makes it totally uniformly flat. And at the same time, surface tension is pulling it perfectly smooth. This ribbon of fire then glides along the molten tin, slowly cooling until it becomes a solid, flawless sheet of glass. This one elegant idea, it made high-quality glass cheap and abundant, enabling all those glass-walled skyscrapers and giant picture windows that define our modern cities. So, there you have it, a process that feeds billions by capturing the air, a process that powers our digital reality by printing with light, and a process that builds our cities with a river of fire. Just three hidden world-changing discoveries that are all around us every single day. Now, here's a question we'd like you to think about. Knowing that these massive, world-altering processes started as just a single clever idea, what everyday problem do you think is just one ingenious process away from being solved forever? Let us know your thoughts in the comments below. And as always, stay curious.